T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And liftoff of Intelsat Galaxy 31 and 32. Go Falcon 9.
Vehicles pitching downrange.
M1D chamber pressure is nominal.
Successful liftoff of Falcon 9 from Space Launch Complex 40 at the Cape Canaveral Space Force Station in Florida. We're carrying the Intelsat Galaxy 31 and 32 payloads to orbit. Now, we've just begun throttling down the Merlin 1D engines in preparation for maximum dynamic pressure. And we've also begun to tilt the engines. That's called gimbaling, and that's why we've begun to move horizontally away from the launch pad. That maneuver is called a gravity turn.
Max Q.
So call out there for max Q, that's the point of maximum aerodynamic pressure. Now briefly going back to the gravity turn, we are still heading up. As you can see, the speed and altitude are increasing, but we're also heading away from the launch pad. And we do that because a rocket needs to go about 17,500 miles an hour horizontally in order to avoid being pulled back to planet Earth. So we'll keep speeding up the vehicle to get to orbit. Now coming up in about a minute, we've got three events back to back. That is main engine cutoff, followed by stage separation, and then second engine start number 1. Main engine cutoff is where we'll shut down all 9 of the Merlin 1D engines on the first stage. That's in preparation for stage separation, where the first stage will push off the second stage, and then second engine start number 1, where we'll ignite the Merlin vacuum engine on the second stage. So again, MECO, main engine cutoff, followed by stage separation, and then SES-1. And gotta love those beautiful views. This is a view from the first stage camera looking down the body of the first stage towards planet Earth. You can see the Merlin 1D's plume expanding as the density gets less and less.
MECO. Stage separation confirmed. And back ignition. Stage 1 FTS is saved.
Awesome. So MECO, stage sep, and second engine start complete. Now coming up next in about 20 or so seconds will be fairing separation. Again, both of these fairing halves having flown 5 times before today's mission. And some great views of planet Earth behind the Merlin vacuum engine.
Fairing separation confirmed.
So there is successful fairing separation. We'll be attempting to recover those fairing halves again once they make their way back to Earth on a recovery vessel named Bob.
Acquisition of signal.
You can actually see one of the fairing halves in frame there as it goes back to planet Earth. We actually got our first glimpse of the payload as well today. As a reminder, we are not attempting landing on our first stage. So the next major milestone will be second engine cutoff number 1. That's about 4 minutes from now. And again, the reason we're not attempting to recover our first stage today is because today's payload needed a little more performance out of Falcon 9. And so we had to use the propellants that we would normally use for the entry burn and landing burn to instead take the payload to orbit. Now, the first of these 2 burns is taking us into what's called a parking orbit. So that is a roughly circular orbit that we'll be going into before we take a second burn later on in today's broadcast. And ultimately, the payloads will be going to what's called a geostationary transfer orbit before they continue their mission onto geostationary orbit. So for this first burn, the Merlin vacuum engine is continuing to burn and take the second stage and the payloads to orbit. Now, the Merlin vacuum engine is extremely similar to the Merlin 1D engines. It does feature more redundancy and a much larger expansion nozzle, and that allows us to maximize the efficiency of the burn in space. And the reason that that expansion nozzle makes the burn more efficient is because we're able to expand the gases further in the vacuum of space than we are on the ground. On the ground, we've got about 14 pounds per square inch of pressure from the atmosphere pushing down on us. And so as you try to expand a gas, you have to keep the pressure matching with that atmospheric pressure. And that means you can't get as much push out of the gas out of the nozzle. But in the vacuum of space, we don't have to contend with that. And so we can actually get more of the force out of the expanding propellant to push the second stage, and that increases the efficiency. And Merlin Vacuum operates with the highest efficiency ever made for an American hydrocarbon rocket engine. Now, you may have noticed on the pad that the second stage looks very similar to the first stage. It doesn't just look similar, it has the same diameter, it uses the same metal composition in the tanks, the same computers, and the same propellants, and almost the same engine. And that allows us to use similar tooling, design techniques, and systems to build two rockets that are more reliable. Anything that we learn on the first stage often applies to the second stage and vice versa. Now, if you're just joining us, welcome. You're watching our webcast coverage of the Intelsat Galaxy 31-32 mission.
Trajectory is nominal.
You've got a view of the second stage Merlin vacuum engine, along with planet Earth behind us. We're about 4 minutes in to a 5-minute burn. We had successful liftoff, stage separation and second engine start, as well as fairing separation from Space Launch Complex 40 at Cape Canaveral Space Force Station. And we didn't attempt to recover our first stage today, as we needed the propellants for additional performance to get our payloads to orbit. Now, we're currently awaiting second engine cutoff number 1, or SECO 1. That coming up in just about 20 seconds from now.
Terminal guidance.
Stage 2 FTS is saved.
Expected loss of signal, Cape Canaveral.
MVAC shutdown.